Earlier, we proved that if the greatest common divisor of P and Q, then the totient of the product is the product of the totients. We proved it by setting up a grid with the numbers 1 through PQ and eliminated numbers that weren't relatively prime to P or Q, leaving us with phi of P columns, each with phi of Q entries. So remember, a good strategy for learning mathematics is to prove it again. So let's try a different proof. So again, sometimes every problem is a nail. So suppose our greatest common divisor of some number of x and p is 1. What can we say about x mod p? Well, suppose x is congruent to r mod p. This means the difference is a multiple of p. Now suppose d divides r and d divides p. Then d divides x. But if the greatest common divisor of x and p is 1, then d has to be 1, and so the greatest common divisor of r and p also has to be 1. So another useful strategy in mathematics is to consider the converse. But remember, don't forget to pay for it. The converse is often useful, but it isn't included like the contrapositive, so we'll need to pay for it. Suppose x is congruent to r mod p and the greatest common divisor of r and p is 1. Then again, x minus r is a multiple of p. If there is something that divides both x and p, it must also divide r. But since the greatest common divisor of r and p is 1, that common divisor has to be 1. And so as before, the greatest common divisor of x and p is 1. So putting the two parts together, we have the following. Suppose x is congruent to r mod p. If the greatest common divisor of x and p is 1, then the greatest common divisor of r and p is 1, and conversely. What this means is that in our numbers, where we'll assume that p and q are relatively prime, the numbers x, where the greatest common divisor of x and p are 1, are exactly those that satisfy x congruent to r mod p, where the greatest common divisor of r and p is 1. Likewise, the numbers where the greatest common divisor of x and q are 1 are those that satisfy x congruent to r mod q, where the greatest common divisor of r and q is 1. So let's consider these numbers. Note that each number solves a system of congruences, x congruent to a mod p, x congruent to b mod q. Since we've assumed that the greatest common divisor of p and q is 1, the Chinese remainder theorem applies. And so there is a unique solution mod pq. But since these are the only values mod pq, this means there is a unique value in our sequence that satisfies the system of congruences. This means we can identify each number in the sequence with the remainders a and b. So if the greatest common divisor of a and p is 1, then x will be relatively prime to p. If the greatest common divisor of b and q is 1, then x will be relatively prime to q. Now suppose the greatest common divisor of a and q is 1, the greatest common divisor of b and q is 1, but the greatest common divisor of x and the product pq is not 1. Then some prime r divides both the product and x, and since prime factors can't be split, r must divide either p or q. But if it divides p, then the greatest common divisor of x and p is at least r, which means that the greatest common divisor of x and p is not 1. Similarly, if r divides q. So if both are true, x will be relatively prime to pq. This means that the only values x relatively prime to pq are those where x is congruent to a mod p and b mod q, and the greatest common divisor of a and p is 1, and the greatest common divisor of b and q is 1. There are phi of p values where the greatest common divisor is 1, and phi of q values where this greatest common divisor is 1. And that means there are phi of p times phi of q values where both are true. So we might try to characterize the numbers x relatively prime to 72, that's 2 cubed times 3 squared, then compute phi of 72. So if the greatest common divisor of x and 72 is 1, then x has to be congruent to something mod 8, where the greatest common divisor of a and 8 is 1, and x has to be congruent to something mod 9, where our greatest common divisor of b and 9 is 1. So a could be one of the things relatively prime to 8. So it's 1, 3, 5, or 7. And b could be one of the things relatively prime to 9. So b could be... So there are 24 numbers that are relatively prime to 72. And so phi of 72 is 24.